Hello, CE495. All right, I think we had a great the second week of class yesterday, and after architectural students' presentation, we walked through just a one example of the Rhino and Grasshopper into the SAP for 2D truss analysis, right? So just in case some of you didn't have a chance to install the Rhino Grasshopper SAP, please watch this video and follow through. I think I encourage you guys to actually go through at least a 3 time different way, right? And just get familiar with this overall the workflow. This is one of them. I think from the industry leader. I want you to have some kind of more the skill than just conventional engineering skill. All right, so I just repeat a little bit briefly that this is the Rhino3D. I think Rhino 7. I have a version 7, but you guys had the Rhino version 8. The Grasshopper, when you open it, it depends on, but if you try to open the file I sent you, example 1 Truss, right? It opened the Grasshopper after they open the Rhino, right? But they'll ask some plugin needs to be installed, which called the Launchbox. So you see the Launchbox plugin. So the first day I told you you guys can download all these Grasshopper plugins from Google Drive. But if you didn't do it, I think still you can install it. So when you see the pop-up menu that the Launchbox wasn't installed, you need to click and download it and install. Once you installed, finished, I think you need to close the Rhino and reopen it. Okay, so Rhino recognize this Launchbox plugin. So yeah, here it's pretty straightforward. It is not really a big item. That just how to draw the line. In order to draw the line, you need to define the origin point here, 0, 0. Yeah, this is x, y, z coordinate 0, 0, 0, and the move in x direction. Obviously, they calling the vector, and I just here show the 24. This is number slider, right? This number slider is a variable, but here, okay, I need to change the unit just in case. When you click the Rhino, Grasshopper, the file is automatically open some default the Rhino file, but sometimes it open with the millimeter. So what you can do, go to file and new, and choose either fit here or fit here, right? Smaller, doesn't matter, small, so that your Rhino setting, unit setting, you should use a fit, because we are studying the beam. The span length is gonna be a 48 feet. Okay, going back to Grasshopper here, right? So this is number slider. I set 24 because I'm gonna draw the half bay of truss first and then meter, so that make a total of 48 feet long. So I want you to just look through it. If you want, just look through it and just do it from the 0. I think what you can do, basically, either you could click each component from the menu, but I'm sure you don't know how to start it. But if you double click, right, so it kind of show this enter search keyword. So sometimes if you put 0 to 20, let's say 100, right, you can create this number slider like that, right? So I'm gonna delete it. Also component point, yeah, obviously there is the menu, but maybe point, yeah, you could find some, but I don't remember all these names, so sometimes I look through here, vector, or here, point, constructor point, I'm gonna find that each component from the menu. But anyway, just for now, just go through this and get familiar with it. If you're really interested in Grasshopper, I'm gonna give you another example with something for the dome structure. So maybe next week we're gonna try one more time. That's something a little bit big 3D scale. So that I want you to find a couple of reasons to learn this Grasshopper. Right? We use architect and engineer use many cases for complex geometry, and as I said, the Rhino is a more worldwide design tool than most of architect. I'm saying most of architect, not most, 100% architect use Rhino for their design phase. All right. So when you move copy it, you can draw the line, but basically it's easy, right? So this is kind of showing the workflow. You plug, drag and drag, drag in, out, drag in, so that you connect it, this dot. So this is workflow. So once you draw the line at the bottom, you're gonna copy the line in vertical Z direction by the some feet, which this example I use a 2.4 feet. So just follow. If you can switch around here, or if you want, maybe you can use 2.4 here. Instead of using this, you could just plug in directly, right? You don't need if you don't want to use this formula, you can use this, right? So the reason why I try to explain that the typical the starting the truss depths over the span lengths. So I just set it up this way, but you can just kind of walk through, click each one, and see which each components their functions, so that you could just kind of understand that each procedure is similar to coding. It's not much different. This procedure will be most likely same as any coding, even including Excel. So now this component is a lunchbox component to the truss. You could see if you install it, there is the right to the truss, right, component. So if you click this, yeah, you see that these components drop. So you need to define basically the line curve, bottom curve, and top curve, right? With this input and truss type 1, 2, 3, I just keep the 1, and it form the truss line, right? So basically after this, we complete this truss geometry set. Now with all, because it gives us the individual discrete component, primary line, which top chord and bottom chord, bracing is diagonal bracing, and vertical line, vertical web member. So I bring all together in the curve, and I select this the line and meter around about to kind of this X Z plane. So I just meter it. So I copy another truss on the second half. So merge, I combine all this, right? So once you do that, you can go right click and bake into any layer. It doesn't matter if you don't have any layer, you can create you can create the layer. Right click, right click and new, right click and new, right click and new. Yes, it's just similar to the CAD, nothing different. So click, select this, merge, and click the bake. I'm gonna save each bake the geometry into the layer 8. All right, so I think basically we bake, right? So I'm gonna just double click and enlarge this. So basically you see that all the line is baked. So based on the fit, I select this, and next time, yeah, since I complete the geometry, I'm gonna export this geometry so that I can create the import into the SAP. So here again, example 1 and truss. Now I'm gonna export those line geometry by using IGS. See that IGS.IGS file, right? So if you save it, it asks what is the unit. We're gonna keep the fit. So I already now I create the file, IGS file. So open the SAP. When you open the SAP, just make sure the unit is fit. right? And then go to File, Import. Obviously, this procedure is most likely identical over all the software, so you should have already sense. So I think the learning new tools, I think you cannot use, you cannot read through all the manual and read and learn one at a time. I think using all previous knowledge, you can just figure it out. Majorities, you can learn faster if you're using your previous knowledge, right? All the current software most likely is been established a similar way. So now I'm gonna import the geometry by using import menu and IGS file. I click that, and then I'm gonna click, where did I save it? I think this one, example 1 truss. So it's IGS file. I'm gonna bring, and I'm gonna click so that this is curve entity. I import it. Okay, so import it now. See, because we're using XZ plane, right? So I'm gonna click this XZ plane. So now I brought all geometry. Up to now, it's not engineering. This is just a skill, right? You need to have a couple of skill, but because of most of structural engineering design works need to establish a geometry. So now, so during the class, at that moment, I'll kind of walk you through that couple of items. First of all, try to show you how to get started the SAP. I think I maybe give you a little bit one-on-one session, but generally, this procedure is also pretty much the same over all the structural software. So now, what you need to know is just checkbox. This is still okay. This checkbox. So you can turn on and off, right? So basically this is display option. So I am gonna uncheck the visible. So I'm gonna turn on the node joint, right? You see the dot? So this is joint turn on and off. So I turn on. The first thing I'm gonna do, I'm gonna select this two nodes because this is support. So I'm gonna assign boundary condition by using assign join restraint. So this is boundary condition for all the support. So when you click this assign join restraint, here is the presetting, right? Fix, pin, roller, or free. So translation is XYZ. XY is global, 1, 2, 3. XYZ, the translation movement. And each node also has a degree of freedom, right? The rotation. Our case is pin, so we don't have any restriction, but only we have a restriction on XYZ movement. So I'm gonna click. You see that if you using this fast restraint, you could use it, right? But basically we are using pin. So I'm gonna assign the pin first, so that 2 pin, but truss on the right, we're gonna make this roller, which means, so we need to allow that this point is moving in X direction, right? So first of all, you need to understand the global axis, the global the axis. So go to click the 3D, you see the X, Y, Z, right? So this is a global coordinate system. So based upon that, I'm gonna release in the translation 1, which is X direction. I release it, make the roller. All right. So boundary condition is assign. Okay. Now, so I think the geometry done boundary is done. But if you click this right, select and right click, you see that default section property is W18 by 35, which is default is too big, right? So maybe can use, I'll show you the bring this other section for initial learning. So okay, let me just do that later because I think maybe show you the beam deflection as well, but just let's keep it. But what we're gonna do is go to define, and we're gonna create the load pattern, right? Load case. As default, we have only download, but yesterday we just create unit and just other, create another one with the 0 multiplier, because 1 is means this download cases, ETAPS and SAP is gonna calculate their self weight of the structure. But we're gonna use a unit load case. I'm gonna select at right is a window selection, right? Left button and hold down, drag and hold down. I think you should know that everything because it's not every software most likely works, CAD and Revit. So I'm going to select this node. I'm going to assign, right, join, and force, right. I choose the units in the vertical Z direction. Yesterday we assigned 20 kips, right? 20 kips, and make sure the unit kip, right, vertical Z global. So say okay. So I assign the 20. All right, so I think, but this boundary condition goes off. So checkbox, we're gonna turn on the restraint. So yes, okay, the boundary condition is ready. Also, before you run it, I'll try to show you so that another beam example. So I select all this line, right, with the nodes, go to edit, and replicate is Control R. So I'm gonna just copy this one, maybe 60 feet, so maybe closer. So I copy this top core. So basically this is beam versus this truss. But problem, the difference is, or same thing is, we are using W18 by 35 as a default. So this guy on the beam, but truss, since we have only one section properties, this member is going to be, every member is W18 by 35, which is not apple to apple comparison, right? But for analysis, we can just let it run. So here, so I'm going to go to analyze and set analysis option. Since this basically 2D analysis on the XZ plane, right? X direction and vertical Z. So we don't have to run 3D, and click this XZ plane, so which is active the plane that I'm interested for analysis. So say okay, and then click this, run analysis. We don't have to run all this basically, but it's okay, it's run fast. So I'm gonna say running. Okay, I'm gonna save, let's say example 1. So when you run the model, all right, okay, what first thing you're gonna get is deformation shape based upon Delo self-weight, but we're not interested yet. So first things, you maybe want to check the bending moment diagram, right? So here, all output display, right? You could go through it here. Show force, stress, frame, tendon, right? Basically, we want to see all the member forces. So either you could go here in the menu, frame, cable, tendon, right? You see the display frame forces, but we are interested unit 20 kips. So first thing, as you see, is okay, beam, deflect. So that what you need to check is bending moment diagram, right? It's a P times length divided by 4. With the point loading, the beam length divided by 4 is typical bending moment diagram. I'm sure everybody knows this, right? If we have a uniform line loading, it's WL squared over 8. I think this is something easy. The formula is commonly used. I want you to memorize it sooner or later, okay? So this case is because this is only single beam member, is showing beam the bending moment diagram. But what about shear force diagram? You can guess it. The shear force diagram. Wait a minute, something is not right. Oh, shear 3. What shear? Hold on a second. What? It should be like this. All right, just try to wrap up that the procedure. So after you run the analysis with the point loading, here you could turn on the display, object and joint, unit loading. Yes, we assign 20 kips at the middle span, right? So after analysis done, you could check the forces, moment diagram and shear force diagram and deflection. So first, yesterday we walked through 20 times 48 divided by 4. So that's maximum bending moment. 20 times 48 divided by 4 to 240, right? So you see the 240. Now, the question is truss, because truss is using truss form, so that this internal bending moment, right? Because of the truss, this configuration, the forces is primary force is not gonna be a moment, it's gonna be in the axial force. I just explained that when you have something wind is pushing you, your two legs gonna experience compression tension. Is rocking, right? Basically, wind is blowing your body and generating overturning moment. But moment, since we have two legs connected by the body, which here top and bottom chord is tied with this vertical and diagonal members, so that all the moment it will be decomposed into the axial force, right? So truss is primarily taking the axial force. So here roughly, let's see, 2072 versus 469. So roughly 70, average 70. Let's say 70 times 2.4. I have a 168 kick foot. The moment is off because something that I didn't include, because so all the member basically, since I imported, is all fixed it's not pin connection, is really all the fixed connection connected. So what I'm gonna do is I select all the member. Top chord must be continuous, right? Top member and bottom member is all continuous. Instead, all this vertical and diagonal member, I'm gonna release the moment, so make the all truss element, which doesn't have any bending contribution. So basically I select all the vertical member and assign some joint release. Make this pin connection. I'm sure you heard about the pin similar to here, right? Pin connection doesn't have any bending or rotational stiffness. So let's run this model again. So roughly, I'm just trying to show you apple to apple, and it's same horizontal member, but if you're using truss, obviously you need to, what is the primary forces is the actual component, right? So it's about 70 something. It's still a little bit off. 77 times 2.4, yeah, 184, slightly lower than 240. Maybe did I miss something? This is actual 477.
What if an appliance emergency didn't have to be?
Yeah,
if your
so
appliances suddenly decided they were done, don't stress. Best Buy has you covered with a wide variety of major appliances from trusted brands, in stock and available now. So you don't have to worry about laundry piling up, refilling the fridge, or that big dinner party you're hosting. Because Best Buy has the knowledge and expertise to get you the right appliance for your home. Learn more at bestbuy.com. Best Buy. Imagine that.
It's almost Saturday, which means it's time to lock in your picks on the field and on DoorDash. With DoorDash Streaks, you can win every week this football season. Order great foods like the Biggie Bag from Wendy's and stack up the savings on foods, drinks, groceries, and more. Up to $250 over the season, including $100 in DoorDash credits. Just try not to go full mascot when the deals hit. DoorDash. Order every Saturday. Stack up the savings. Win every week. See DoorDash.com. Terms and exclusions apply.
Sweetie, come here. Don't worry. I see a lot of patients with the exact same thing.
Ever since the ice skating
maybe
rink went in
because of
next
bending
door,
is because of
Dr.
truss
Clark's
current
business is heating
profile,
up.
So many
so
patients need my
that
help.
there will be some
Will I find time to see all
moment
of them?
component,
They need to hire
or
a
the
scheduler,
truss is
stat.
I
really
need Indeed.
Indeed,
delivering
you do. When you sponsor a
some
job on Indeed, it's easier for talented
the
candidates to find it,
forces
which makes it
into
easier
this,
for you to hire them. Visit
shear
Indeed.com/credit and get $75 towards your
forces
first sponsored
form.
job.
So
Terms
we'll
and
double
conditions
check
apply.
Later, because there's something maybe we need to kind of investigate a little bit. But basically, I want you to check the bending moment here on the right, by clicking unit loading bending moment 3. So it's about the 20 kips times 48 feet divided by 4. You have a maximum bending moment at the middle span is 240. But in the truss, you need to look at the actual force. Okay, so maybe I'll create a couple of different the truss configuration. Probably depends on the truss configuration at the middle span, the top and bottom chord, the actual component might be slightly varies through this finite element analysis. All right, so I think this is wrapping. It's gonna end of today's class. But I think I found that some things has some glitches or bug. Let me double check and get back to you.